Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 235. Oh, very hard problem for me anyway. Number of different subsequence GCDs. So this one, there's actually a little bit of a thing as well. I took a long time to solve this in general, but I got two wrong answers, two time limited exceeded answer in Python for a reason that I actually wasn't paying attention until I switched to Java. And we'll go over that. But this is a tricky problem, but the idea is the SIF of I never know how to say it correctly, but the SIF of Eurostat. How do you spell it? Okay. Erwatodes? Okay. But yeah, this is what I would Google on. You're having trouble with this problem in general and just getting over just understanding what this problem entails. But basically the idea is that, okay, it's just counting for each number, how many different pairings are there for a given I, right? So for a given I, how many GCDs are there of I, right? How many subset are there with a GCD of I? And that's basically the way that I did it. And this is roughly n log n, where n is 200,000, or maybe u log u, if you want to call it that, where that is the domain. So first of all, we set off the frequency table, but basically we count, how many subsets there are with GCD of I, and this is almost like, count together, right? Yeah. So the count, we start with f sub I, which is just the numbers that we see, but we also want to see how many numbers have a divisor that is I, right? And here we start with 2, for example. We go, okay, let's say I is equal to 10. Then we know that numbers that have a GCD of 10 would be, with 10 would be 10, because GCD of 10 and 20 is equal to 10, GCD of 10 of 30 is equal to 10, and so forth, ... So that's basically what this does here. We count the number of counts, and then we also count the number of overlaps that we already did. And of course, we have to, we'll talk about the margin in a second, but basically here we count the number of overlaps, and what that does is that we don't double count numbers, so that if we do 5 later, here this is going to be 5, but the number of sets here we want to subtract. We want to this is just basically going to be actually, GCD of 5 and 10 is 5, but we also want to subtract the ones that are in 20, because then they overlap in that way, and that because we already counted them and we don't want to double count. And then at the very end, people are cheering near me. I don't know why. Maybe it's because they just finished the contest as well. Anyway, so then at the very end, after we go through all of this, after we go through max, then the number of overlaps of I, so that we save it for the future, is, this is just the number of subsets which are going to be used for the overlaps. But yeah, and that's just the number of count. And this number of count is just the number of counts that are of these numbers in the array. So F is the frequency table of all the numbers in the array. So yeah, that's just the numbers. So now it counts all the numbers that have this number as the GCD, and for that, as you can tell, because for example, if there are 8 numbers, then you can imagine that any if there are 8 numbers, then you choose what I is one of the numbers, and then all the other numbers. I think actually another way I could have optimized was making sure that this is greater than 0. But that wasn't gonna be fast enough anyway. But yeah, if you have 8 numbers that contribute to this process, then there's going to be 2 to the 8 minus 1 number of subsets, because you have 8 numbers and every number could be in the subset or not in the subset, and then you minus 1 for subtracting out the case where there are no numbers, because that doesn't make any sense. So basically you get this and then you minus overlap. And yeah, and if this number is greater than 0, we add the total, because that means that there's a distinct I, which is the question asked in the answer, the answer asked in the question, and then you just return the number of total. So this is roughly n log n. This is I'm not going to go over that analysis that much, because this is something that's in the CIF of the CIF, say, so u log u, say, and yeah, and it's just something that kind of you just have to know it. I know it, but I'm not able to kind of explain it in a quick way. Short answer is the sum of the series sums to u log u. But you can, for further research, just Google that out. But the tricky part is that if you do 2 to the count, however, count could be a really big number. Count could be, say, count could be, I don't know, 10,000, right? So if you have 2 to the 10,000, this is going to be a really big number. You're going to use a big integer, and that's when it times out. And so to get around this timeout, we added a mod so that we bound the number of digits by not as big of a number. You bound it by a smaller number. However, you do have the risk of getting a wrong or like a false positive. But there are ways around it. I got lucky choosing a constant that didn't have any false positive. But if I did, then maybe I would have to do it in 2 places or something like that. But the idea is, just like, same thing with hashes and stuff like that. And if they're equal to 0, then probabilistically the 2 numbers are equal and so forth. So yeah. But you need this mod to kind of speed it up, and yeah, and this is what I have for Python. This is going to be n log n and O of n space, or O of u space maybe, because u is the maximum number that's in the list. And for my Java friends, I did submit this problem in Java, so check it out here. And this is actually, I didn't think about this until I did it in Java, the mod thing. This is why I did it in Java. Because I was like, oh, this can overflow in Java. So then I actually wrote my own mod pal to support it, and yeah, and you could see me try to mostly copy and paste from my Python solution. But yeah, so if you're in Java, check out this solution. And if you want to check out the mod pod is here, but this is more standard. So yeah, so the CIF is the answer for this one. Let me know what you think. It took me a long time because I played around with a lot of different algorithms, including just like playing around with the devices, trying to figure out different ways of doing brute forces in a smart way. But I guess I always knew it was going to be the CIF, but it took me a long time to really figure out how to do it with the CIF and going backwards and double counting and stuff. And you can watch me solve it live during the contest next. Thank you. Yeah, one more thing, because I wanted to go over just looking over code reviews, and I saw some way clean solutions that were way easier than mine. And actually, to be honest, this is kind of what I was trying to think about how to do, but I couldn't do it correctly during the contest. So that's why I got a really confusing answer. So hope you stayed until now, because the earliest thing. But looking at code review, just going with here, this is again the CIF, same algorithm that we talked about, but this is the other way, where again, the loop on the outer loop asks, okay, for an answer X, what is the, is there a way to get X as the answer for some sequence of GCD. And then basically here, we just go through all the possible multiples of x and go, you know, for if it's 2, you go 2, 4, 6, 8, and you look at all of them, and then you GC them, all of them together, because if you GC more and more, it would only give you possibility of seeing x. And that's basically the idea, really, is that if, because the minimum of this G would be x or 0, I guess, if it's not used. But yeah, but in this case, but yeah, let's just say, you know, G has a minimum of x because all these numbers are multiple of x. And if there is such two numbers such that the GCD of two of them is equal to x, or two or more of them is equal to x, we increment. And that's pretty much it. That's a really cool answer. This is n log n, of course, as in the CIF, or u log u in the same notation. Definitely try to understand this one. Even me, I didn't do it during the contest, right? So, you know, don't feel so bad, but definitely, yeah. Because basically what this is saying is that, okay, for all multiples of 2, for example, if x is 2, all multiples of 2, is there a GCD of, you know, some of, or all of them? Because if all your, because the more numbers that you add to a GCD, the lower the GCD is. But because your GCD will be at least 2, because they're all multiples of x by definition, where x is 2, you know, if you GCD all of them, you'll get either 2 or none. So that's 2 or a bigger number, I guess, is what I mean to say. And if there is an existence of them such that it's equal to 2, then you increment. And it's a really, yeah, I mean, it's a really nice solution. I wish I thought of it, because I did some crazy things, and I even got 2 wrong answers and stuff like that, because I did it kind of the inverse problem of this, which is really confusing. But yeah, I think this is a way clearer answer. So yeah, let me know what you think. This is basically just a way of brute forcing or n square solution, kind of in a way by taking advantage of the time complexity of the CIF, which again, I implore you to kind of look it up. Yeah, that's all I have, and you can watch me solve it live during the contest next. Silly. Okay. Mod. No mods on this one. Remember the mods. Can't believe I forget the mods. Don't have any idea yet. Don't apparently someone already got it. How do you get 7 from this? Is that right? I guess so. I don't know if this is right, so let's see. Really? That was my second attempt. Come on. Let me just print something. Okay. That's not right then. Oh, minus, no. Oh. That's 8. Did I mess up something? I guess so. That's maybe just luck. I don't believe this. I don't think this is right. I messed up on my assumption. Let's see. How many people have gotten this so far? Oh, people have gotten it already. The mods suck. I would have been like top 10. Oh well. I think this is just luck, to be honest. That this is right for these answers. This isn't even right, but this is 5, 10. This is 5 and 10. So that's also wrong. And the answers are is it sufficient to look at every 2 pairs? Is 2 an answer? No, I don't think so. Yeah, no, actually this should be 40 and 2 times 2. We could just remove this, I guess. No, 2 is an answer, 3 is an answer, 5 is an answer. What are the other answers? Oh. Oh. It's 15, 40, and 6, but and 1. What if this was 10? No, what if this was 12? Then 2 would not be an answer, then it'll be 4. What's the max divisor? Is that too slow? Maybe I should have done it locally. So 17. No, that's not what I want to do. That's not the number of devices, that's just the number of unique primes. So what I want is one sixty times 10 to the 5th. 16 million should be okay. Maybe. No, I don't think that's right. I mean, that's right, but I don't think that helps enough. Because at that point we're just how do I do? If only I didn't make those two mistakes, I would be happier. Because this is maybe a hard one. So if this is a 5, then this has to be 2. So we can't really separate them. So in this case, there's no 2, so how do we take out the 2? Do divide and conquer. Well, it's the intersection of 2 numbers. So 3 numbers will never make it a better answer. So you're always only looking for pairs of 2s. So what did I say? The biggest number was 160. Well, no, it would give you. It could possibly give you a distinct number. So if you have someone like this, and then this, then 2 times 5 is an answer. it so far. A lot of people got it, so I guess I'm just the only one stuck. Those two long answers are killing me. Wow, I just lost today. Also, the two thing is not true routing. You can have this. And the answer is 2 times 5, which is 3, but it doesn't appear in only 2 of anything. Well, that's not true. Is it? Don't know. I have an algorithm, but I don't think it's right. I don't know if it's right. Also, just because you have this doesn't mean that this is not a correct answer for 2. Number theory is hard. That's not right. Oh, whoops. Too slow. Should be fast enough, but And it's twice as fast. Come on. Is that the same case? Maybe. Nope. I mean, it seems fast enough, but I need to do one more optimization, I guess. Why is this that slow? I mean, this shouldn't be that slow. This is... I guess this is mostly 0, so I have to optimize this a little bit. Hmm, 22 minutes optimizing. I feel it's such a terrible penalty. If this is right, it should be okay. Pretty fast, but not correct, unfortunately. Oh, I forgot a for loop. Is this the right answer? It's pretty fast, but this is gonna overflow, so I need to be smarter about it. That's probably why it times out in Python. Like it. 1, 2, 4, 5. Automate. Yeah, this is definitely wrong. As a result, but really fast. Still no easy mod power in Java. Other than big int. That's annoying. Oh, that's not right, unfortunately. Why is this too slow? 9331264. Missing 4. YOLO. That was a hard one for me. I don't know. A lot of people got this one. So. Yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Hope you had a good contest. I did okay. I was Q4 was a little bit tricky for me, but yeah. Let me know if you have any questions. Join me on Discord, and I hope you have a great rest of the week, rest of the month. Take care of yourself. Take care of others. Stay good. Stay healthy. To good mental health, and I will see you in the next problem. Bye bye.